Imagine an artificial intelligence that can actually develop itself. No, really, this isn't some, far-off science fiction plot. It's the surprising reality of a project called Wally the Wobot. And today, we are taking a deep dive into its recent releases. We're looking specifically at versions 0.35 and 0.36. We've got quite a stack of fascinating source material here, release notes, technical explanations, all showing just how fast this system is evolving.
Yeah, it's moving quickly. And our mission for this deep dive really is to understand these surprising steps Wally's taken, well, self-development, and also how it's starting to tackle real-world problems like critical open source maintenance. And maybe even more interestingly, the unexpected challenges that pop up when an AI, specifically an LLM, starts writing its own tests.
Right, and what I found really striking in the sources was how Wally is basically building the tools it needs to improve itself. That's quite something. Okay, so let's unpack this. How did this whole self-development thing really kick off?
Well, what's fascinating, and where it really starts, is how Wally version 0.35 introduced a really crucial feature, MCP server mode.
XCP server mode, okay.
Yeah, essentially means Wally itself now acts as a server. It communicates mainly through STDIO, standard input-output, which allows it to talk directly, internally, lets it interact with GitLab tools without needing anything external.
Huh. So, wait, if I'm getting this right, it used to rely on some external GitLab MCP server, but now Wally is the server itself.
Exactly.
That sounds like a pretty fundamental shift in how it's built. The sources also mentioned this happened within Claude Code, which they seem to prefer over, say, Open Code or Google's Gemini CLI. Found it more effective, apparently. So what are the immediate upsides for its development cycle?
That's right. It's a huge change.
Yeah.
And it accelerates development significantly. It lets Wally build new features faster. And this is the really remarkable part, to actually self-develop. With this integration, Wally gets direct access to all the GitLab stuff issues, comments, merge requests, files, the whole lot, which dramatically streamlines the whole end-to-end operation. Really, the only third-party piece left in that puzzle is the code loader, like Claude Code.
Wow.
So yeah, the key insight is that Wally becoming its own MCP server isn't just like a technical tweak, it's a fundamental shift.
Yeah.
It turns it from just a skilled worker into, I don't know, a sort of self-sufficient internal department head. And that just massively speeds up its own development.
Department head, I like that analogy. That's a huge leap. But even a self-sufficient department head needs feedback, right? How does Wally make sure that its new internal tools, its self-generated code, how does it know it actually works?
Absolutely. That's critical. And a key realization during Wally's development was just how necessary it is for these agents, these parts of Wally, to understand and use CI/CD.
Continuous integration, continuous deployment.
Yeah, for validation and crucially for that feedback loop.
Okay, and how is Wally actually using that? Because getting that real-time automated feedback seems absolutely vital if you're trying to iterate and self-develop this quickly.
So Wally leverages GitLab CI. That gives the agents real-time feedback on things like code conformity, unit tests, coding style, even code format.
Yeah.
And the critical part is, this happens no matter where the agent is actually running. Just by making commits, pushing to GitLab, Wally gets that immediate feedback.
So it's not just getting feedback, it's automating how it gets it too. The sources talk about Wally automating creating issues, documenting CI tool access, all directly from Claude Code. And then it incrementally implements and tests these new tools itself. It sounds like a closed loop, like it's constantly learning.
Exactly, and that's where version 0.36 really comes into play.
Yeah.
It specifically gives tools to the multi-agent system and the MCP server so they can inspect CI pipelines, jobs, logs, everything.
Oh, okay.
This creates this incredibly fast feedback loop. It enables that rapid iteration and evolution for Wally. It really is a continuous cycle, learning, improving, getting instant insights into its own performance.
That rapid iteration piece sounds key. So, okay, what does all this mean for Wally's path towards maybe full autonomy? Where is this heading? Can it really act on its own?
Well, the next big step involves enabling that MCP server to send real-time notifications straight to the agents. Real-time notifications.
Yeah, basically turning GitLab to-dos, new issues, comments, things like that, turning them directly into actionable tasks for Wally's agents.
So it's almost like GitLab hands Wally a to-do list, and Wally's server just immediately pushes those tasks out to its different parts to get them done. What happens if this fully autonomous task distribution really works out?
That's pretty much it. The current path is towards a kind of hybrid model. Wally, as the MCP server, manages these real-time tasks from GitLab's to-do list. But Claude Code might still handle some of the, let's say, implementation details, like documenting an issue or implementing a merge request. But yeah, the ultimate goal is for Wally's multi-agent system to autonomously distribute and implement the work itself, at least for simple tasks, simple issues, and merge requests. And if that works for the simpler stuff, the sources hint this could potentially remove the need for Claude Code entirely. They even suggest maybe reaching that point as early as next week. That seems incredibly fast.
It is. It really speaks to the pace of development here. But, and this is important, it's crucial to note that a hybrid mode will likely stick around for the more complex tasks.
Okay, that makes sense.
Yeah, you need that close collaboration between the human and the non-human agents. It ensures the system can handle tricky problems, with human oversight. It's about finding that sweet spot between full autonomy and smart human AI teamwork.
Right, keep the humans in the loop for the really complex stuff. That makes perfect sense. But speaking of real-world problems, one application that came up in the sources that kind of surprised me was about helping open source maintainers. Can you tell us about that? It feels like a bit of a shift, maybe, from pure self-development towards societal impact.
Yeah, it raises a really important point. What about the serious challenges facing maintainers of critical open source projects? The sources use libxml2 as a prime example.
libxml2, I know that one. It's everywhere, isn't it?
Exactly. It's incredibly widely used. Major companies, banks, Google, Facebook, governments. It underpins systems that impact literally billions of dollars globally.
Billions, wow. That's a staggering scale. But beyond just that one library, what are the sort of deeper systemic problems that make maintaining open source so difficult? And how could Wally potentially change that, not just for libxml2?
Well, the core issue is often that these maintainers lack resources. Money, time, sometimes just goodwill. And they face immense pressure. It sometimes leads them to do things like publicly disclose security flaws without an embargo.
Oof, yeah, that's risky.
Huge risk for everyone relying on the software. It's a massive burden on just a few people maintaining this global infrastructure.
So how could Wally step in to help with that burden?
So a really compelling idea is to use Wally's multi-agent system, use the LLMs, to assist these maintainers, help with bug investigation, diagnosis, maybe even proposing fixes. The aim is to significantly ease their workload.
Okay.
The plan, as outlined, is to test Wally's abilities on libxml2 first as a proof of concept. See if it can investigate, diagnose, potentially correct minor bugs. That would be a genuinely valuable contribution to a critical, but often pretty overlooked, part of our digital world.
That is a very promising application, using AI for, clear positive impact. But
Right.
as Wally gets more autonomous, especially writing its own code, writing its own tests, have there been any unexpected hurdles? Because we know LLMs can sometimes, well, they can hallucinate, right? Generate weird stuff.
Yes. A significant challenge actually comes from the LLM-generated tests themselves.
The tests? How so?
Well, they often produce test suites that are just way too broad, or they end up testing GitLab's behavior instead of Wally's actual tools. And sometimes they include assertions that are totally out of scope.
Can you give an example? What was particularly imaginative, let's say?
There was one really striking anecdote. Yeah, an LLM-generated test tried to check for SQL injection in a random string.
SQL injection in a random string.
Yeah. Chuckles lightly.
Yeah.
It was completely irrelevant. Wally's role there was just calling GitLab APIs. It wasn't doing anything with SQL. It's that kind of imagination or hallucination from the LLM, not based on what the code actually does, that can lead to useless tests or even counterproductive ones.
Wait, SQL injection in a random string, that sounds like the AI is just, I don't know, throwing spaghetti at the wall, hoping something sticks. How often are you seeing these kinds of creative but ultimately pointless tests? What's the real cost of dealing with them?
It's a pretty significant burden, actually. These kinds of issues mean multiple review cycles. We're talking at least 3 or 4 passes sometimes. And it needs direct human intervention in what they call planning mode, basically, a structured human guidance phase, just to make sure the unit tests focus on the right scope, that they only test functions actually in Wally's code. And the sheer volume of LLM-generated code that needs that careful human review, it causes a substantial cognitive load. It's a lot to check.
So even with all this autonomy, this self-development, human oversight is still absolutely critical, especially for quality control, making sure the AI is testing the right things, not just anything it dreams up.
Absolutely. And what's interesting here is that the CI feedback, that continuous integration loop we talked about, was vital in spotting these inconsistencies. Seeing the difference between the LLM-generated tests and how the code actually ran, that helped refine the process.
Okay.
But this whole experience really reinforces the conclusion. Fully automated workflows, probably best for simple tasks. For complex issues, though, especially given that cognitive load of reviewing tons of LLM code, hybrid workflows are preferable. You need human oversight at key stages.
Yeah.
So the ongoing effort now is really focused on continually refining those LLM-generated tests, trying to get the scope and relevance right from the start.
Right. So just to recap this deep dive then, we've seen how Wally the Wobot isn't
Mhm.
just software, it's more like a self-evolving system. It's integrating tightly with CI/CD for really rapid iteration. It's moving towards this fascinating hybrid autonomous future. And it's even thinking about how AI can support the unsung heroes of open source. But that journey isn't totally smooth, right? There are these complexities, especially around making sure AI-generated code, particularly tests, is actually accurate and relevant.
Exactly. And if we sort of connect this to the bigger picture,
Hmm.
as systems like Wally get more and more capable of self-development, of taking on critical tasks, and given these nuanced challenges that, still need significant human oversight, it does raise a big question. What does this all mean for the evolution of human skills?
Hmm. What new kinds of collaboration, maybe even entirely new roles, are going to emerge as humans and these advanced AI systems start working more closely together than ever before?